So just to repeat what I was saying earlier, if you're finding yourself stuck on a specific answer, just writing out the answer or specifying what that numerical answer is going to be, particularly for these efforts, is okay to do. This won't, of course, account for any changes that may happen to the number of D types. So, Alden, I hear what your question is. You've got value counts, and you've got this being returned as a specific series. But it's not actually getting that first answer, specifying the object or the integer, isn't quite working, right? Like you can't get 9 output originally, and you can't get 6 output. I'm going to have you answer this question. This is a series. That means that this operates very similarly to a list. The lists are the items that we worked on yesterday. So if you had a list that was the objects 9 or 6, let me ask you, how would you try to index to output or return the first value in this case?
Could you pop it?
You can pop it. Let's think about list indexing first. Go ahead.
Would you update it?
You can update. Update is really more of a function for dictionaries. So update might not quite be ideal for this.
Okay.
Let's think about yesterday's list. We had summer, we had fall. And remember when I said, hey, I want from this list, I want to return summer. Yeah, Aaron's on there. Why does 0 work? Aaron, if you want to go ahead and explain that.
Python is 0 indexed, so it's going to pull the first value from the series.
Yeah. So in a list, you can index through specific values and call those values individually. So if you want 0, or if you want fall, you would index for those values. That's how lists work. Okay, let's take this back a step. This is how lists work. If we take value counts, and we understand that a pandas series works the same way as or operates very similarly to a Python list, we can begin to understand that this object still works like a list. So let me go ahead and ask, if this is a list, and this is a 0 indexed list, how do I return the values for object?
Would the shape of that be 2 columns and 2 rows?
Not quite. Actually, if you were to try looking at the shape object, not sure. Yeah, you would actually see that it returns 2 rows, but no columns. That's because a series is still very much a one-dimensional object. We'll talk more about this once we go into matrix multiplication and things like that in 2 weeks. So not something for you to quite worry about right yet. But what's helpful to think about is that if a list is a one-dimensional object, technically a vector, and a series is also a one-dimensional object, this object for series actually works exactly the same way as 9 or 6, which means that if I were to index for this list for 9, I would return that first value. Same would apply if I wanted to return that second object for 6. So this value counts still working the same way as a list. If I wanted to return that second object, I would return, for example, integer 1. I would index through this series to specify that I want that object 6. This part gets a little bit tricky because it requires us to think about how lists operate. And in that same front, we have to think about how series operate in that same vein. So we have a list of objects that has 2 objects. We confirmed that with shape. There are 2 rows here. If we wanted to index for these values, say we want our objects to be assigned to that first value. Whoops. Number of objects. I'm just going to assign the number of object to be that first value will be 0. And when I output the number of object is now the number 9. Alternatively, if I wanted the number of integers, just reassigning this value. Because in my value counts, the number of integers is that second object. You still essentially get the same answer. I'm seeing some concerned faces. That's okay. Does anyone need me to go over this again? Okay, cool. Take a look at Slido. Just in case. All right, Slido's quiet. Cool. Weird. Someday I will find out who Anonymous is. It's actually really exciting. Next question, what do we got?
Sorry, did you go over how to get the counts for in 64, like for the assigning for task 3? Did you go over how to get it in a more general sense instead of just grabbing the index?
Oh yeah, I mean, if you wanted to, so like the way you can actually spot it or like determine what those values are. So what you would do is you want to use D types in this case to determine what the D types of those values are. So I'm going to go ahead and comment out these codes, these lines of codes. I must have overwritten that somewhere. I'm going to rerun my cell. Then I'm going to go back to 3. Okay, interesting. Did I not assign the columns properly? I did not assign the columns properly. Column headers. Read CSV. I didn't actually read this in properly. Oops. That's got to go there. That's got to go there. Sorry, folks. Names equals column headers. All right, that looks a little bit more normal. All right. There is a thing. So if you needed to find what those values are, you could very well just how many values of integer 64? That's 1, 2, 3, 4, 5, 6. Objects 1, 2, 3, 4, 5, 6, 7, 8, 9. You can do it that way, and you can assign those values in that fashion. That's what I did earlier, where it was just number object is equal to 9. This is fine. But you can also just use value counts, which is, again, my favorite function, where we'll aggregate those numbers, those results from that series, and count them up into 9 and 6. So that's just, those are 2 ways you can essentially, you can index for those values, or you can just assign the values, the numerical values itself. Logan, what you got?
I don't got anything.
Oh, okay.
Just to follow up, is there a way to select one of those 2 values? Like if I wanted to just select, like if I just wanted to do run a single line to get number in 64, is there a way to select in 64 from this single line of data types?
Yeah.
Thing that you ran?
I mean, the fastest way, the most efficient way is to just index for it, like process for that value. Technically speaking, you could also, let's see, Do I have index for this? Yeah, so you can also index for the value and specify index int 64. No, it's not gonna work either. Do. Value counts. This is going to be way more complex than it needs to be. Value counts equals 6. And then from there, I would do that index, create a mask for that, and then it returns integer 64. I don't like that. That's messy.
I think
So-
you're doing the same work twice when you're doing that.
Exactly, yes. So, but to explain, just to show you what's happening, because it's important to at least know what's happening. Let's take a look. So we have value counts, and the question was, how do we identify the values for 64? Well, you can technically specify, oh, I want the value that is 6, because when you return that value, you create a Boolean from the series itself. And from there, it's a matter of specifying, I want the index. This is interesting to note because this is how we add to the .loc methods that we learn later on. Whenever you surround these values to a specific, like as a list, what you're doing is essentially creating a mask that you can then apply to the value itself later on. So you can essentially call the value counts index and specify, I only want the true values or the true Booleans from this series value that I created. But that list has to come from and identify only the index. This is not good code. But it is helpful to know that this order of operations is how one value fits on top of the other. For the most part, try to stick to indexing because it's just faster. Let's not spend too much time because I don't want to confuse y'all. Follow-up questions.
So I did it a completely different way. I found a select underscore dtypes method.
Cool.
And I had a question about that because I sent you a screenshot, Julian.
Okay.
Because when I go to print out the output, it gives me the dtype at the bottom, and it says the int 64. But my question was, why does it say that under the object one, two? Take a minute to look over if you need.
Yeah, totally. So you got select dtype, include numbers. I love this actually. Let's play with that. All right, so. Yeah, so the reason both values, okay, so for starters, the reason both values print out, it's because number select dtypes, it's essentially you're doing a couple of, like you're doing one of those things where you're doing different jobs here, or you're multiplying, you're doubling up the efforts of the process itself. So if you were to do select dtypes, so if you've got columns, if you wanted to do a select dtypes, what select dtypes does is that it returns a subset, like it works directly on the data frame itself. So it looks at the data frame columns and it looks for which one of those columns you might be interested in working with. This presumes that you know what kind of data types you're looking for. And perhaps in this scenario, we actually already know that we're looking for integer 64 as one of our dtypes. And as you can see, what dtypes does in this particular scenario is that it returns as a data frame all of the data columns that are recognized as integer 64. So integer 64 are values in our age, FNO, whatever that is, education num, capital gain, capital loss, and hours per week. Those are still 6 columns. Now, Martha proceeded to look for all the numerical objects, which is great. And then she specified, let's look at the data types. We already know that the data types are those objects are already numerical values. So this is kind of repetitive, but it's really excellent because we still understand that the answer is going to be 6. And from here, she finished up with value counts. And this is also an interesting solution because value counts just returns the number of categories in that specific series. So we've got 6 returned as a value, and then it's specifying at the very end, because value counts will always specify at the very end what D types you're working with at any given point. So that's just one of the functions of value counts and how it operates. Martha, to simplify this code, one of the things that I could suggest, if you were so inclined, is to actually just use, Len is going to return the data set size itself. One thing you could do is you can actually identify which of those columns actually are integers. So you apply the dot columns parameter, or the dot columns are that method, and you then count how many columns there are in this data set. So there's 2 ways you can do this. I'm going to go ahead and take this back. You can count the number of columns. That gives you the number 6. Ben, and I know I saw a few questions pop up on Slido. If you deleted them, fine, no worries. You feel free to put them back. I'm going to try to address as many of them as I can. The other thing you could do, instead of using columns, is you can use that shape method. Shape returns the number of rows and the number of columns. This brings us back to indexing, where you can specify by indexing your values this second number. And this is how you get that 6 again. So we're at task 7 and task 12. Perfect. We'll go through that. This is great. Any follow-up questions to this?
It's not a follow-up question for task 3, but if nobody else has any other questions, I have one for task 6.
Okay, let's get to task. Let's take this in order because we do have questions for
Okay,
task 7 and 12. So we'll just essentially go through this notebook. Are we being recorded? Yeah, cool, perfect. How to change column names. Task 1. How do you can you specify a little bit? Change column names. So for task 1, what we're doing in this scenario, you want to create a column list, very much like we did in class, where you just take all of the column names, these values that are present in the in that list of values, and you want to create column headers. And then in order to add column names to the value itself, we're using the names parameter from the read CSV data set. Remember, read CSV data set has an argument that allows you to specify which of the column names you want to be specified. So interesting thing, I'm actually going to remove one of the column names just to show you what happens if the size of your columns doesn't fit in with your data set. It will line up as best it can. But then what happens? We get shorted one. Don't we get shorted one? We're supposed to get shorted one. It's supposed to line up on the index. Right, income. So when you remove the income, you'll see that the value doesn't actually line up properly. So this is one of those things that you want to be very careful with when you're specifying your index values. I'm not entirely sure which one got thrown off from the get-go. So be careful with that your column names and your number of columns line up in this scenario. But remember, what you're using is the names parameter from your read CSV method. task 4. I'm not going to do that one because that's just asking to return the shape. This shape method, you can essentially do the same thing and index through your values. So if you're working with adult dimension and you're working with adult.shape, let me take this a step back. So if you're working with adult.shape, I'm gonna hyphen this out. This is a 2-object tuple. You can specify an index for objects the same way. So the number of rows is your index 0, and the number of 1 is 15. And that's if you want to create a just one object thing. So adult dimension, it's adult shape. That should work. It's a tuple. Missing values. We're clear on how to find missing values. We're not having to drop that. Task 6 was the describe. Before I keep going, anyone struggled with task 6?
My question for task 6 was just
That's right.
basically rounding down to 2 decimal places, because
Ah.
I've got a pretty huge float, and that's obviously
Okay.
not what.
Totally. Excellent. Adult data frame. We're looking for the mean age and assign it to a variable called mean age. Hours per week. Okay. So adult age. I want just the column. In class, we talked about how to get the mean of a value. You essentially call the mean variable. That's a huge float. This is the part where I go back to that, how do you cheat? Like, is it cheating? No, because it's working, but just because it works doesn't mean that we're cheating. Look, if you were to type out something like this, I can't stop you. That's a value rounded to 2 decimal places. It's not fancy, but it works. So with that said, let's actually find a way to make it work. There's a couple of ways we can do this. With Python, what's actually nice about the round function is that it works exactly the same way as round in Excel works. It is a function that is built into Python. As you can see, you can specify your first argument is the number that you're choosing to include. Remember that this object, adult age mean, is 38.58, 164, 67, et cetera, et cetera. And if you use that comma, the number of digits, just specify to what given precision do you want to round this to. That's where 2 pops in, and you can specify that you want to round your object to 2 decimal places. Another way you can use the adults dot mean method for rounding is the dot round parameter for pandas. This works exactly the same way. You can round objects to, whoops. Is there not a round function anymore? What am I thinking of? This become
It worked for me.
Must be a version thing. I mean, it's not because it's not a panda series. I get it. It's because it's not a panda series. I see. Okay, so I'm doing this on a panda series. It's not going to work. Round on floats. Nah, okay. Okay. Weird. All right, so disregard what I was just going through, because clearly I was going through some outdated version of something, clearly. This version essentially rounds up your values to 2 decimal points. And with that value rounded up to 2 decimal points, you can assign your value to mean age and have those values rounded down. I'll let you do the standard deviation. You may need to figure out how to do a standard deviation in pandas. For anyone who's seen that, you can go ahead and throw that into the ES36 channel. All right, I have a question on task 7. Let's take a look at that. Any other questions about task 6 before I move forward? Summaries. Sorry, go ahead. Okay, let's take a look at task 7. This one's requiring us to use the describe exclude number. This is what we talked about in class. If you take adult.describe, exclude number. This part gets interesting. This part gets tricky. So say we are looking for the number of unique education values. So education, it's right here. That's 16. Again, I can't stop you from doing this. I just can't. It'll work. It'll work in AutoGrader. It'll work in CodeGrade. I'm letting you know this right now because this is like if you're stuck during the sprint challenge and you figure out that this is the best way you can go ahead and do it and it works and it's coded, just go ahead and do it. However, if you wanted to filter for specifically accessing this individual value, there's a couple of ways we can go about doing it. And these 2 questions essentially ask for the same thing. So when you run this object, you're returning a data frame. You check out the type. This is still a data frame. Let's actually take this moment. Whoops, I just closed everything accidentally, sorry. Let's actually take this moment to talk a little bit more about .loc. So this is a data frame. And it works with the values itself. You can index through a data frame the same way you can index through, think of it as a battleship game, where you go either from right to left to specify the column value and then link down. This is one of those things that helps to think about, and how you choose to process this is up to you. So for example, say I want the number 16, I can filter for the values in education. And you'll see, what does this create? A series. So because I've already created a series, this operates the same way as a list. And when it operates the same way as a list, we can index through the list. So this would be your 0. How would I index to achieve that value for unique? You can use your fingers to show this off. There you go. You index for 1 and you get the number 16. So that's one method for you to kind of navigate through the data set in a way that allows you to filter through the values through the value that you've created. However, there is another method that programmatically works a little bit faster, because it's not that much faster really, like to navigate from the column, create a series, and then let me reframe this. So this is a 2-step process. For this, I need to create a series, and then I need to index through the series. 2 steps. What .loc does is that it essentially takes this process and combines it into one immediate grid search pattern. The problem with .loc is that, one, it's kind of tough for new folks to figure out. .loc is a pandas data frame that kind of has quite a bit of documentation, but it's essentially made for filtering, indexing, and or using conditional variables to kind of to define or recreate your data frame. But it can be a little bit tricky to figure out if you're not somewhat familiar with code languages from the very get-go. But one of the ways that you can begin to think comfortably about the .loc method is to think of it in a grid format. .loc, that first value, refers to the rows or the index values of a data frame. In other words, the rows. So if I take a look at my data frame, my .loc or my index are these four values: unique. So when I specify unique, what I get returned is a series value with all of the column names and the values that pop up under that unique row, 9, 16, 7, 15. But rather than going through the filtering process of filtering for the column itself, so I was going with unique, I can add a comma and specify I'm going through unique. I need my other index for education. And you'll see it returns in one step or one processed step, the value that's currently at 16. Any follow-up questions? So, yeah. To be fair, you could do that too. So I'm seeing some of you commenting, it was like, oh, overthinking and misinterpreting, I was trying to find unique. So the other way you could do this is if you take adult.value counts for the education column, there are 16 values here, 1, 2, 3, 4, 5, 6, 7, 8 through 16. Here's another way that you can solve this question. Just count the number of rows in this series. You'll see it returns the exact same thing. Technically speaking, this is easier for y'all.
What I did was I did adult, what was it? Here, let me see. What was it? I just did unique underscore education equals adult education dot n unique, and it gave me 16 without having to. Because where was it?
Yeah, that works too. That's what we did in class. We just kind of went through that part very quickly. So, oh, then that's correct. So unique will return all of the unique individual values. That's what I should have led with. And unique will just return 16. This might have been a red herring. I'll make sure to remove that from my next portion. Value counts, indexing, red herring in 7. I don't like red herrings. All right, so 3 different ways to answer that question. Let's see, questions for Cascade. Someone figured out task 8. Cool. Does anybody else want to take a look at task 8? Task 8 is pretty much the same thing. Yeah, you're right. I'm not going to go over task 8. Don't get it. Oh no, it was task 12. That was a question about task 12. Okay, so we'll get to task 12. This is create a series. This is just create a column value. I'm going to go ahead and skip that because you all know how to create columns, I presume, at this point. I'm going to run task 10. That is pd.read CSV data URL. That is, what am I calling this? House. Task 10. Create a new feature. Are we comfortable with creating bathrooms? Hands up if you need like. Okay. Okay, so new columns. Task 12. Yes, cool. This works. Y'all, this one has the answer right in it. Accidentally left this in there. Check your notebooks. That's your answer. Okay, let's take a look at this in a couple of different ways. Sorry about that. Okay, so let me just go ahead and explain this answer. So, wow, I clearly did not update this last notebook. Sorry, folks. All right, so what's happening here is that if you take lot area and you filter or create a Boolean condition for all properties in lot area where they are greater or equal to 10,000, you'll get a true false Boolean value. And that true false Boolean value will specify as a 0 for false and a 1 for trues. Now, in order to get specific as to how to assign it, we're going to go over that too. But in most coding practices, a large lot, let's go ahead and create that large lot and specify my true and false parameters. And if we tried to view that new column, there's lot area. There's a typo. Let's make sure I've got this clearly defined.
The second L is supposed to be capitalized.
Yeah. Second L, lot area. Okay.
And large lot is supposed to be capitalized.
Guys, assume that's a lot. That's a assert statement. Yeah, perfect. Thank you.
Welcome.
All right. So here's our Boolean value. So this is the method that we got stuck in a little bit in class. I sent a Loom video to kind of go over what to do with multiple conditions. Let's actually go over it again because this can be tricky using the .look method. Because this method is asking us to specify whether these values are 0 or 1. And there's a couple of different ways that you can specify that value to create those parameters. So, but this, technically speaking, actually works a lot faster because true and false, when it's specifically a 1 or a 0, is just going to run a lot smoother when it comes to some of the modeling processes you're going to deal with. However, sometimes you're going to deal with situations where you might need to categorize multiple values or create multiple categories for those values. So I'm going to go ahead and comment out this code, and I'm going to rewrite large lot using that, that Boolean method. So to start off, let me not start off with the house look. Let's talk about getting this information brought together. So if you bring this out on its own, let me comment that out. So everything's being commented out except this. This is what's outputting out. You see that this is a true and false statement. This statement, because you have the same number of index values as your original data frame, you can apply that value to the data frame itself. Note that I'm doing exactly the same thing as I would do when I'm creating a series. If I were to call, I don't know, sale price of the house, it does exactly the same thing. All I'm doing is that I'm instead specifying a very specific mask to this data frame parameter. Valid syntax, probably somewhere. Yeah, that's string. Stop. Okay, syntax. So this is my data set with all of the values where the lot area is greater than 10,000. Now, of course, our goal is to create a new data set that has, wow, this is a big data set, that has 1 and 0s instead of trues and falses. That's a big one. So for this, we can actually use that .loc method once more. Because .loc not only just works as a mask, as a matter of fact, if I run this, excuse me, this will return the exact same thing. It'll actually specify, well, not exactly the same thing, I apologize. It will return, yeah, exact same thing. The same data set with the with only values where the lot area is greater than 1,000. And as part of that process, remember, loc works by looking at the rows and then looking for the column name. So with this process, if I just specify that I want large lot, spelled correctly this time, I have now highlighted that I want all of the values in large lot. If I run this, I'm only returning the true values from the large lot values that I created earlier. And now I have a Python series that I can rename. And I can rename that or reassign the values to 1. Before I run this, I'm going to take this, kind of go over this once more. We understand up to now that if I want to specify the conditional values, I get all of my trues or falses. These are all 14,000 or 1,460 rows. I want to specify that I want these rows to be part of a mask. So house specifies 10,000. Now I'm only returning the true values. Sorry, I'm scrolling over to the right. All of these values are true for the large lots. If I use the .loc, I'm specifying the same thing. I return the same data frame. But now I have the power inside the loc method to call on the column name. So that's my large loc. And if I run this, I create a series of only the true values. And if I want to rename all of these series, all of the values in this series to whatever it is I want it to be, say I want it to be, I don't know, candy, I can do that. You see it works. If I remove this, all of my values are now candy. But we can specify that to be 1. I'm going to remove that just so that you can see how this has changed to 1. All of the values are now 1. So that's my first value. I still want to reassign my values that are less than. For this, it's a simple matter of I just create another line of code where I change all of my values to be under large lot, and all of my values are now 0. And now, if I check the values from this new column that we've just created, we now see that large lot and lot area is either assigned to 0 or 1. Follow-up questions? Sweet, Sam. Okay. We're going to do this again for the tougher one. Anyone interested if they want us to do the tougher one? This is the part that gets tricky. Because this is the part that requires more than one specific condition to be met. Also, Logan caught this. There is a typo in this cell. It should be MO sold, not mod sold. Sorry about that. So now we're asking to create a new column called summer sale. Let me go ahead and hyphen that out or hashtag that out. And in this case, we have multiple conditions needing to be met. Now, you can essentially create a for loop where you specify if every value in this, like to specify which of those values gets highlighted. So let's take a look at house, most sold, most sold. Because now we have more than just 1 or 2 conditions. We have 12. So this is the part where there's a little bit of a logic puzzle that's required to kind of think about this. Because all we need are the values for 6, 7, or 8. So you could very well specify that house sold is 6. You see that most of these are false or true. And then you can specify or house most sold is equal 7. You see a problem start to work because the truth value of this series isn't quite working properly. So too many conditions. You can actually use the or in this scenario. It doesn't work either. Cool. A lot of that has to do with the fact that I haven't actually specified which of whether both values can be true. So this is where pandas and parentheses need to come into play. Because now this is accounting for the 6s and the 7s. Or the values for 8. As you can see, we get a few more trues out of this one. Why does this not work? Or why does it run but not process anything? Is because there isn't a value that is both 6 or that is all 6, 7, and 8. It's all either or it's either 6 or 7 or 8. But then that means you have to specify for one variable whether this is 6, 7, or 8, and then you have to apply this to house. And now you've created a data set that this is getting a little messy, so we're just going to go ahead and show you. This is now returning only the columns. There's 609 columns where it's only 6, 7, or 8. I'm only showing you this so that we can see what Python's doing behind the scenes. There's an easier way to process this. We only have 12 numbers. And of these numbers, we're only trying to find values that include 6, 7, or 8. So we can include this as all values, let's make this simpler, easier to read, equal than or greater to 6. And all values that are less than or equal to 9. This creates my first conditional. There's a typo somewhere. Yeah, there it is. You'll see that it returns the same number of rows, 672. Understanding what we've put into practice so far. We have our mask. We just need to specify the loc. And with that loc, we just need to specify the new column we're trying to create, summer sale. If we run summer sale on its own, something didn't work. Loc, summer sale. Here's a typo somewhere. I'm just going to go ahead and grab a copy paste so that I don't have to spend too much time looking for it because I am. Where is it? It's the typo. Okay, so that works. Loc. Oh, okay. Yeah. Summer sale. I see what happens. So the value. Oh, okay, I see. So nothing happens because I haven't actually specified what I want to create on this column. Summer sale, it did the grid point search. And this column, summer sale, hasn't actually been created yet. So let's go ahead and create it for ourselves by actually assigning a value to it. And because our instructions are specifying assign summer sale to 1, now we've actually got a value running. And if we were to take a look, something. if we were to take a look at what we've created so far, you'll see we've got a bunch of null values as part of the other parameter. So now we've got that first part ready to go. We've got the first value already created. And because this is already 1, the alternative is the complete opposite. So the complete opposite to this would simply be all the values that are less than 6 and all of the values that are greater than 9. Because you see that this includes all of the values 1 through 5 and all of the values that are, I got a typo in here. This is supposed to be an 8. My apologies. Just looked up the instructions. All of the values that are greater to 8 will be assigned to 0. Now there's one thing to consider here, because now we're not just looking at 1 through 5 and 9 through 12. This is one of those scenarios where this value gets switched from an ampersand to an or premise. Because in this case, we're looking for all values that are 1 through 5 or all the values that are 9 through 12, as opposed to here where we're just looking for the values in between. It's 2 separate conditions that we're trying to meet in this scenario. And now we've got all of the variables 0 through 1. Yep. All fits. Can anyone take a guess as to why this pops up as a float and this pops up as an integer? That's a tricky question. Okay. Python reads from left to right and from top to bottom. So it essentially processes information as it's being delivered. It'll take this first task and see like, okay, find everything greater than 6 and make that parameter met. Then it'll take this next process for less than 8, make that parameter met, sees these values and create, oh, you want me to create a column with all the values to 1. I understand. So when it creates those columns, it's trying to return a data set or a series, but it still recognizes that are no values present. So by the time it reaches the second condition, it understands that it can only fit float values under the impression that there are still null values or NP not a number values present in that series, because there are multiple conditions that need to be met as part of that parameter. So this is one of those reasons that can be tricky with working with the .loc function in rather than a true or false statement. What questions do you have? I've got a couple of good questions here. Why are the values in the, yeah, oh, okay. Yes, so I haven't seen your question yet. So why are the values in the no column floats and not integers? Has to do with how Python is interpreting the numbers and the null values in that value. Are pipe and or interchangeable everywhere? Not really. So in this case, unless there's been a new Python version that changed on me, let me double check. Yeah, it does not quite work. And the problem is that or is specifically made to work with Boolean operators, not this process of creating a numerator value from that impression. So there are situations where you would use the and there are situations where you would use the pipe. Particularly when you're working with the .loc, with conditional variables in .loc, understand that you may need to focus on using the ampersand and the pipe, and that this is just one of those pandas Python limitations. But they're not quite interchangeable everywhere. me go ahead and correct this. Did I miss anything that I was going to talk about? That sounds good. I'm seeing a few of y'all. You need to calm down, Rob. Export. Also go overload from conditional feature code. That's what we just did. Same Zoom link. Okay, cool. Thank you. Yeah, Zoom link is always going to be the Zoom link. It's going to be the same. Now I go over test 9. Yeah, sure. What was test 9? Test 9. Test 9 was creating a series, creating a list, Panda series. Yes. Okay. Let me ask you this. What is this type of object? You can go ahead and turn, you can just call it out. Turn off your turn off your mic and just call it out.
Is it a series or am I wrong?
If you're ever in doubt, use that type function, built-in function. This is great. This is a great object. It'll tell you, oh, this is a pandas data frame. Yeah.
Yeah, okay.
Data frame is a 2-dimensional object. So follow that up. What is this object?
That's a series, right?
There you go. Yep, that's a series.
Yeah.
A pandas column is a pandas series. A pandas, yes. A column in pandas is referred to as a pandas series. In NumPy, it's referred to as an array. And a data frame is referred to as a matrix. This is a nightmare for a different day. But when in doubt, just check the type value. And you can always check the data type of an object itself. If you're ever in the mood to create a pandas series, there is a function for PD that allows you to create a series from an n-dimensional array. That's what I'm referring to as a NumPy array, as for example, 1, 2, 3. Doesn't quite, like, we'll create a series as long as you specify, like you may just have to specify the index values itself. So for example, 1, 2, 3 is one way to create a pandas series from scratch. You can determine that by looking at the arguments and see that it requires you to specify the data, that's this list value, and the index. Ooh, do I want to specify the D type? Sure, why not? Let's call this, let's make these floats. And it's minor nightmare sometimes. No, adult occupation. Typo. Okay, 5 minutes after the hour. Yep. So yeah, and Ben, the reason you were having problems with, I'm just actually going to copy paste this column, is because when you try to use this method, it's a great start. It runs, but it only runs because what you've created is a string or an index or a series with just one object, the word string.
Okay, that makes sense.
Yeah. So this is what's happening. If you, for example, were to do something like, what's the name of this data set, house, this would create a error. What's the name of this data frame? Wow, I already forgot the name of the data frame. Adult. Brain, come on. Adult.occupation. This will still work too, like, but you're essentially doubling up your work because adult occupation is already a series. You're just sort of reaffirming the fact that it is a series.
Perfect. Thank you.
Okay, well, for those of you who were either watching this recording or in office hours today, we went over the assignment. Pretty much all over it. So if you have any other questions, I know Nivi just jumped on the time. I need to actually cook tonight, so I do need to step off today a little bit earlier. So I apologize. Tomorrow we go into grouping and actually merging data sets from different sources. So that part gets a little bit fun. I suspect that it's a lot less content. We actually try to reuse the same, like I actually try to stick to 5 different functions, which is exciting. So just 5 functions. Knock on wood, hopefully that's true. So it ends up, we end up learning a lot of new things and mostly focusing on the one thing kind of over and over again. So hopefully it's things get to, things don't seem as overwhelming at the state, like starting tomorrow. Knock on wood. I could be lying. I never know. So my apologies if I am. Folks, have a good night. Make sure to get some rest. Don't work on this all evening. There is still time. And if you have any questions, Nivi is available for the next few hours. And if you have any questions for me, feel free to send them my way. Happy to answer them. I'll submit and upload this office hours recording in just a moment. Thanks again. Y'all were great.
Thank you.